So guys, this is Chef Mayhem. Today we're going to be going over how to make black powder with alcohol and water, which is supposedly the best way to make black powder because it infuses charcoal, the saltpeter inside of the charcoal, and that's because charcoal has a high surface area for its size. So yeah, let's get to it. How to make black powder. This is the third version, and it's with alcohol and water. Just so you guys know, I made the slide, so there's no copyright. And it's backed by science because I personally made it and I investigated it, and I made sure everything was legitimate. So about black powder, in case you wanted to know, if you watch my other videos, this is always every black powder video I made has this introduction in it. So just go ahead and watch those other videos. So black powder was first made by the Chinese for use in fireworks. It was then used later on as weapons and explosives in the 12th century. This is during the period of the gunpowder empires and the Mongols. It is very simple to make, but it's not very powerful or safe. Only about 50% of black powder is converted to hot gases when it is burned. The other half is mostly very finely burned particles. Black powder has one major problem. It can be ignited by static electricity, which means you can't put it in like metal containers or other stuff such like. This is bad because you can't use metal at all to make it. So this material must be made with wooden or clay tools, or like those fake rubber spoons or whisk. Anyway, a misguided individual can manufacture black powder at home after reading this guide. Yeah. The ingredients to making black powder are by volume in this method. In science/chemistry, the things things are measured in moles and /mass. Moles are mass. It's like molarity is a type of mass, which is not to be confused with weight. That's why it's used on a balance. It's measured on a balance instead of a weight scale. But this way of making black powder is an exception, since we already know the individual chemical properties and mass and how it reacts. So we know that a certain amount of reactants will get a certain amount of product. So it doesn't really matter whether you use weight or mass, since we already know how much of what gives what. So basically, what that means is we already know that 15. Let's say to make water, you like let's just bullshit and make up some random chemical. Let's just say cyanide and copper oxide equals turns into oxygen and copper. So which actually is true, by the way. That's one of the good purposes of cyanide, besides murdering people. So because of that, we already know how much of what gives what, and it's because we already know the weight of it, we can just substitute the mass for weight, since we know one mole of cyanide is equal to 1 mole of cyanide. How many actually look that up? One mole of cyanide weighs 50 grams, approximately 49.007. So we already know that, and so because we know that, we can just substitute everything by weight. So the ingredients. This is to make 2 pounds of black powder, and you're gonna need 3 cups of potassium nitrate, saltpeter, or you could substitute it with sodium nitrate, which is NaNO3. You then use 2 cups of wood charcoal, 1/2 cup of powdered sulfur, 10 cups of alcohol. It doesn't really matter the alcohol. I prefer isopropyl alcohol because it's just more concentrated. You can usually get that in 70%, and that's it being generic. Then you get 3 cups of water. Try to get the alcohol in 100%, but it doesn't really matter what alcohol you use. The water is going to cancel out anyway. I mean, the water is going to evaporate anyway, so it doesn't really matter. So the materials you need are a heat source, preferably like an oven or not oven, stove, or like one of those portable heat pans. 2 buckets, each 2 gallon capacity, at least one of which is heat resistant, metal, ceramic, etc. So this basically you could just get a big pot, because pots are, you know, heat resistant. Flat window screening, which is obviously is going to be flat. At least 1 foot square, which obviously means 1 foot, 1 square foot. A large wooden stick, which is those paint sticks, and cloth. You can just use a t-shirt. So the ingredients you're gonna need is potassium nitrate. This is brand of potassium nitrate I like to get. Spectracide stump remover. It's 100% potassium nitrate, and you just need 3 cups of this. So yeah, you can interchange it with sodium nitrate, which is NaNO3. That always supposed to be capitalized because it's nitrate. Yeah. Then you have what's next? Sulfur. And then you need 1/2 cup of sulfur. This is a brand I also like to get. It's just dusting sulfur for gardening to make the pH, bring the pH scale down or up, or forgot shit, whatever. Then you need charcoal, 2 cups of wooden charcoal. Now to make charcoal, you just get like wood and get a can, and then a can with a lid, and then like stuff the can with wood, and then put it in a fire. And before you do all this, poke a hole in the can so that the pressure doesn't build up and cause it to explode, because heat is directly proportional to pressure. So if heat goes up, then pressure goes up. And then just put it in a fire, and then it'll all melt and petrify into carbon, which is just charcoal, because charcoal is just carbon, a big lump of carbon. You need distilled water. You don't want any like one of that like sink water, because that's got like fluoride and for your teeth and all those minerals inside of it. And it might have lead in it, those lead pipes. Those darn lead pipes. You need 3 cups of this. Then you need rubbing alcohol, 10 cups. You need two heat resistant gallon pots or containers. Make sure you two gallons. Square window screen, at least 1 foot by 1 foot. You can just take this out of your window and just like put it back. It's not that hard to stick out. You just squeeze it together and it'll just pop right out. But be careful, because don't do this at like a high altitude, because you don't want to like fall out your window, something like that. It's, if you don't really know what you're doing, you might hurt yourself. So don't. Make sure it's a low window. Large wooden stick. You can just use those painter's sticks. Just one. Cloth. These are t-shirts. You can't really see that, but yeah. It doesn't really matter if the t-shirt's brand new or old. You just use cloth. So step 1, place all the alcohol in one of the buckets, all 10 cups. Why do you do this? This is so later on you can basically, the alcohol can mix saltpeter into the microscopic nooks and crannies of the very high surface area charcoal, which is what gives it its high surface area, the nooks and crannies. So put the potassium nitrate, KNO3, the charcoal, and sulfur in the separate heat-resistant bucket. Add 1 cup of water and mix thoroughly with the wooden stick until all the ingredients are dissolved. Why do you do this? This is so you dampen the mixture, so that it doesn't like accidentally ignite when you make it. This also helps the saltpeter get into the charcoal. Add remaining water, 2 cups to the mixture. Place bucket on heat source and stir until small bubbles begin to form. Now, it's important that you don't boil it. You just want to get it nigh boiling. All right. So you don't want to boil it, because then if it might ignite and you lose water. Well, it's not going to ignite because it's in water, but you're going to lose water. So you just want to have like at the threshold of boiling. Then you're gonna want to stir it until you're gonna stir it. And why do you do this? This is so the thing reacts. You know, the this is so the water, the chemical reaction can like speed up. Heat causes chemical reactions to speed up, and it, yeah. And we already know what we're trying to speed up. We're trying to speed up the salt, the solution soluble rate, the rate of solubility. Yeah. What we're trying to make soluble is the saltpeter into the charcoal. Ultimately, the more condensed the gunpowder is, better quality it's going to be. So yeah, that's why you want it to be all into one. And then you want to remove the bucket from heat. And you remove the bucket from heat after the small bubbles begin to form. So remove bucket from heat and pour mixture into alcohol while stirring vigorously. This is to speed up the reaction. You don't want the alcohol inside of the. You wanted the water to mix everything up before you put in alcohol, because alcohol may mess things up. So it's just because I really don't know why you had to put this in. This is one of the things I don't understand. If any of you guys want to any help with this, if you guys are confused about it, then just email me. It's on my channel page. And if any of you are confused about it or like just want to know about it, I'll research about it for you guys. And so why you stir it? You stir it so you can speed up the reaction. Obviously, because stirring things causes the reaction to speed up, because you adding kinetic energy to the molecules, and kinetic energy is basically heat. The kinetic energy of molecules is basically heat, the temperature. Step 5, let alcohol mixture stand about 5 minutes. Strain mixture through cloth to obtain black powder. You don't want to discard the liquid, because you're not going to need that. Wrap cloth around black powder and squeeze to remove all the excess liquid. And this is to make sure that you have any fine powder, not that lumpy, garbage. Step 6, place screening over dry bucket. Place workable. You might want to clean out one of those buckets out, or you don't really need to. Just use the bucket that you put the original potassium nitrate in. Then place a workable amount of damp powder in the screen and granulate by rubbing solid through the screen. If the particles appear to stick together, this is important. Then recombine the entire batch of powder and repeat steps 5 and 6, which is the cloth and the screen. Why do you do this? This is so you get that fine powder. It's the same reason as the last step. You get that fine powder instead of that lumpy stuff. And this way it'll heat up. It'll dry faster, because the longer you have the water inside the black powder, the more likely the saltpeter is going to be washed out, because the black powder is pretty much finished. Remove from heat as soon as granules. This is important. So this is important. You got to spread the granulated black powder on the flat, dry surface so that a layer about 1/2 inch thick is formed. Allowed to dry, use radiator or direct sunlight. This should be dried as soon as possible, preferably in 1 hour. The longer the drying period, the less effective the black powder. Why do you do this? This is because the more you leave finished black powder in water, the more likely it would lose its saltpeter. Because saltpeter is water soluble, so it's going to leave the mixture. So you're going to want to just words of caution: remove from heat as soon as granules are dry, because that might ignite it. Black powder will then be ready for use. And voila, you can now make black powder with alcohol and water. You're officially a scientist. Good for you. So, warnings. Black powder can be permanently ruined by water. This is because it's a mixture of saltpeter and potassium nitrate. I mean, not saltpeter is potassium nitrate. It's basically one of those fertilizers. Um, if it's a mixture of saltpeter, sulfur, and charcoal. Saltpeter is water soluble. If you get it wet enough, those saltpeter can be completely washed out of the mixture. This process that we do right now, this is the 19th century industrial manufacturing process for black powder. Which involves deliberately dampening it to make it less dangerous during manufacture, and to make saltpeter crystals form inside of each particle of charcoal. This is important because it makes it more. It dampens it during manufacturing while it's wet. But when it's dry, it's more powerful. They were careful to use only just enough water. Watch out for static electricity. It will set black powder off. Remember this. And that's it. It's Chef Ma'am signing out. And if you guys like what you see, then just subscribe and email me, and then I'll just see what you want. If you want something, then email me, and I'll see what I can do about it. Next up, we're going to be learning about how to make solid gasoline or solid alcohol, which has loads of fun purposes, like burning it and throwing it through the air. Like like those old medieval stuff where you see like those catapults with like fire in it. I'm pretty sure they don't have solid alcohol in it, but it's gonna mimic the same like process. You could just use it as I don't know, like a slingshot fire, basically. So yeah, that's it. See you guys. Chef Ma'am signing out.